Okay, so in this video we're going to solve equations with radical symbols in them. And one of the most important things for us to know is that after we're finished solving our problem, we're going to have to take our value for x, or our potential value for x, and plug it into the original equation to make sure that the solution that we found is actually a solution and not a fake solution, or what we would call an extraneous solution. So, as has been a common theme this year, when we have something a little weird like this operation is, okay, in an equation, our first step is always going to be to isolate that strange piece. So in other words, we're going to have to move that 1 over to the other side. It should be an obvious first step. So root 2x minus 5 then equals 5. Now we're going to deal with that radical symbol. And we should know at this point that the way to undo a square root symbol is to square. And what we do to one side, we must do to the other side. So the square root symbol and the squared do undo each other. I'm left with 2x minus 5, and then 5 squared is 25. So I'm going to proceed, add 5, 2x equals 30, divide, x equals 15. Okay, now we've got to check that solution, so I'm going to go back to my original radical. 2 times 15 minus 5 plus 1 equals 6. We're not going to check this problem by moving things over to the other side. This is going to become a wall. I need to make the left-hand side equal what's on the right-hand side of that wall. And so it's just some quick math. 2 times 15 is 30, minus 5 is 25. So square root of 25 plus 1, square root of 25 is 5, plus 1 is 6. So these two sides are equal, and this is in fact a solution. Okay? Now a similar problem is this next example right here. Okay? I'm going to start by subtracting 3. So 2 times the square root of x minus 2 equals negative 2. Then going to divide by that 2. So the square root of x minus 2 equals negative 1. To undo my square root, I'm going to square both sides. X minus 2 equals positive 1. And then add 2. So x is 3. So now if I go back and try to check, 2 times radical 3 minus 2 plus 3 equals 1. Well, 3 minus 2 is 1. The square root of 1 is 1. I get 5 equals 1. The two sides are not equal to each other. So this x equals 3 actually is not a solution. It is what we would call an extraneous solution, or a fake solution. So a solution that mathematically we're able to come up with, but when we plug that in, due to a step in our solution process, we've lost some of the values, in particular negative values, and that solution doesn't actually fit. So that's why we always have to make sure that we check our solutions. A couple more examples. Okay, top example here. Add 1, so 2 times the cube root of x minus 2 equals 4. Divide by 2. The cube root of x minus 2 equals 2. Now to get rid of a cube root, I'm going to cube. So x minus 2 equals 8, and x equals 10. I check my solution. 2 times the cube root of 10 minus 2 minus 1 equals 3. That's 2 times the cube root of 8 minus 1. That's 2 times 2 is 4, minus 1 is 3. So that is my solution. And one last example here, probably about as hard as they get. Okay, I've got to get rid of that square root symbol. So I'm going to square both sides. So the radical and the squared are going to cancel. But on the right hand side, I'm actually going to make sure I don't make that common mistake of distributing my negative, and I'm going to FOIL. So x squared minus x plus 1. Move everything onto the same side, because this is a quadratic equation with an x squared and an x in it. So I need to get one side equal to 0. So x squared equals negative 1x minus 6. That's very convenient that I can factor this example so that I do not have to use the quadratic formula. So x equals 3 or x equals negative 2. So let's check those solutions. The square root of negative 3 plus 4 equals negative 3 minus 1. That's the square root of 4 equals negative 4. Oh, that's not going to work. We'll try the other one. Square root of negative 2 plus 7 equals negative 2 minus 1. That's the square root of 9 equals negative 3. That's 3 equals negative 3. Oh, that's not going to work either. Just want to go back here and double check this solution and make sure I did not do anything wrong, because usually one of the solutions works. You know what? I can see where I made a mistake. Should be a positive 3. So 3 minus 1 is 2, and 2 does equal 2. So this was incorrect. X does equal 3. That is a solution. Okay, so sorry for the mistake there. Usually, at least one of your solutions will work.